So what is abstraction? So abstraction means hiding internal details and showing functionality to the user is called abstraction. For example, phone call. We don't know the internal process, but we are enjoying the functionality. You're calling and you're talking with your friend or whoever it is. That's abstraction. What process they have written, what logic they have written, we don't know. But we are not bothered about that internal logic. That's called abstraction. And abstract class and interface are used to achieve this abstraction. And first one is abstract class. If a class contains abstract keyword, then that class is called abstract class. And the syntax of abstract class is access modifier, abstract, class, class name, curly braces. So you can write in the abstract class inside variables, abstract methods, concrete methods, constructors. And these are all the things you can write extra. Here you're getting abstract methods. And there is a concrete methods. What is this concrete methods? Defined methods. So till now we are writing every method is a defined method, right? That's a concrete method we call this. If there is a body and definition, that's a concrete method. And abstract methods means it doesn't have any body. So later you can define this abstract method. So whichever the way you want, you can define. So this is the abstract methods means. So abstract method has only declaration, doesn't have body. So that is called abstract method. What is abstract method and concrete methods? Abstract method, just a declaration will be there, no body. That means curly braces reason won't be there. That means you are not defining the logic. You are not implementing those methods in this abstract class. You will implement later in the separate class. That's abstract methods means. And concrete methods means which are going to be defined. And you can write even constructors also. And you can declare different types of variables, static, final, and non-static variables also you can declare. That's what this abstract class. And the syntax of abstract methods is abstract void method name, parenthesis after put a semicolon. Abstract void method name, so data type P1. Abstract data type method name. So you can write a return type methods, you can write a void methods, data type P1. So abstract class needs to be extended to another class to implement the abstract methods. So we'll use extends keyword here. Abstract class needs to be extended to another class to implement the abstract methods. So we'll use extends keyword for this, and we cannot create object for the class. We should not create object for this abstract class and interface also. And we can achieve only partial abstraction, right? With this, see, you're hiding only partially. Remaining methods, you are showing the logic. So there is no logic and you cannot use them, right? That's why we should not create object for any abstract class. And abstract class doesn't support multiple inheritance. Why one class can extend to another class only, but you cannot extend multiple classes. That's why abstract class doesn't support even multiple inheritance also. So let's see a simple example here, abstract class. So here we have an abstract class, a car class we are creating. In this car class, we declared a string model, string color, and max speed. So this is the key properties of a car we defined. So here I am declaring two abstract methods, public abstract void gas. public abstract void break. These are the two methods just declared but not defined. And next, so all the set model, get model, set color, get color, set max speed, get max speed to all setters and getters we created. Okay, so that's a raw class. This is just a raw class, right? So we are not creating. So we don't want directly use this because there are many types of cars are there. That's why it's an abstract class, just a blueprint. And so this is not a very simple abstract class, and so nothing special in that, right? So why we need it? Why we need abstract class? So first of all, it is describing our required car in the most abstract way, whatever the possible way it is described in a blueprint. So there is a reason why you are using this word abstract is in the real world there are no abstract cars. So there are only trucks, race cars, sedans, or SUVs. So such kind of cars you have, but there is no abstract cars. And that's the reason we are giving that abstract cars. Again, we are going to create. Our abstract class is simply a blueprint. It's a template. So we'll use that template to create a different car classes. You can create a different car classes. See that like this. Public class sedan extends car. So now it will ask you, okay, which cars you haven't, which car methods you haven't implemented, and you can override them here in this sedan class. So you can see that's just a gas method I put, right? System.out.println, the sedan is accelerating. Then public void break. So the sedan is slowing down. So this is the really exist one. Sedan is exist. And you can apply all the methods for the sedan. So that's how simply we are creating a real use case we are creating. So this is very similar to what we talked about interface, right? So inheritance. So did you remember what we are doing? Same as inheritance, right? So this is the inheritance we are applying here. And again, overriding is coming here. Method of overriding also coming here. So two OOPS concepts we are using here. But we had a car class and its methods weren't abstract, but that solution has a number of drawbacks that are fixed in abstract classes. So first, and you cannot create an instance of abstract class here. See that you can just car equal to new car, so it will throw an error for you. So the car class is abstract, that's why you cannot create object for car class. So that's not possible. It won't allow you to create object for any abstract class. So Java's creators specifically designed this feature. An abstract class is just a blueprint for future and creating a normal class based on that. You don't need copies of the blueprint. So just you don't create an instance of abstract class. So here you can see, but if the car class doesn't an abstract, so we could create the object, right, for that class. That if I am creating a normal class, so that I can create object for that. So a car object is created, right? A car object is created here. And then, so now our program has some sort of incomprehensible car. It's not a truck, it's not a race car, it's not a sedan. It's totally unclear what it is. If you create object, what kind of real entity is that? Can you tell car you are telling? Car is a generic term, right? So what kind of car? Is unclear for us. So this is the reason very abstract car that doesn't exist at all and very important to make that kind of things abstraction you can apply here. So you can apply same example for animals also. Imagine if an animal classes abstract animals, it's unclear what kind of animal it is, what family it belongs to, and what characteristics it has. It would be strange to see that in our programs. There are no abstract animals in nature. Like we have only dogs, cats, and foxes. So such kind of animals you can represent. They really exist. That object, if you want to represent, and you make normal classes, dog class, cat class. We already created this, right? Cat class and dog class. So abstract classes deliver from abstract objects. They give us a basic state and behavior. And for example, all cars should have a model, color, and max speed. But you should be able to apply the gas and brake for the particular car. So that says this is a general abstraction plan. So next you design the classes what you need, what kind of car you need, you design it. So that's the advantage here with the abstract class. You can define abstract methods. Those methods you can define for other classes. So here we implemented two methods in the abstract class, right? Are also designated as an abstract. So then they don't have any implementation. The reason is the same. Abstract classes don't create default behavior for abstract cars. Any abstract thing, you won't create a behavior. You'll just declare them. That's why abstract cars doesn't exist, and that's why you won't create object for them. So these abstract methods indicate what every car should be able to do that. It's common for every car. So such kind of things, what you can do, you made them abstract methods. Then later in your own class, you define your own way for the methods. So that will save our time, and you can give a different logic for each method in different classes. If you do need a default behavior, you can implement methods in the abstract class. Default behavior you need, you implement, but you don't want a default behavior. You want to write a different logic for every class, then go for the abstract methods. So that's how we implement it here. So you're just creating normal. If you want it like this, and it doesn't matter, we can create a setters and getters, but that doesn't allow the implementation of abstract methods. It doesn't allow implementation. So you can just declare the methods. So sedan car you can implement. So only brake we are implementing here. Or gas you want, you can implement, but I don't want this brake should be implemented. For other classes also I can implement this brake differently. That's why I made it abstract. This is the advantage. So when the some methods you want to make a default behavior, implement that in the abstract class. You don't want to implement default behavior, and you want to give a different logic for every class for that method, and you go for the abstract methods, right? So we have implemented first method in the abstract class and not the second one. Same way in the sedan class we are implementing that. Sedan class behavior is divided into two parts. If you call the gas method, so the call rises up to the car abstract parent class, but we override the brake method in the sedan class. So this is the how you can flexible way you can write however you want. So if a class is abstract means at least one of its methods is abstract. Remember this point. If your class is abstract class, at least one method must be an abstract. If abstract method is not there, you can create it a normal class. Why you want to go for abstract class? So at least one of the methods should be an abstract method. The remaining you can implement. So we can even implement all the methods and leave none of them abstract. Then it would be an abstract class without abstract methods. In the principle, this is possible, but the compiler won't generate errors. But it's better to avoid that kind of situation. We should not do that. The word abstract loses its meaning if there is no abstract method in the class. Okay. Make sure if you're creating an abstract class, at least one method must be an abstract method, right? So at the same time, if a method is marked with the word abstract, each child class must implement it or declare it as an abstract. Otherwise, the compiler will throw an error for you. So these are the points we should remember. So each class can inherit only one abstract class. So in terms of inheritance, there is no difference between abstract and ordinary classes. So it doesn't matter if we inherit an abstract class or an ordinary one, there can be only one parent class, right? That's what that means. Multiple inheritance is not supported even for abstract class also. It doesn't matter whether it is abstract or normal class. Why Java doesn't have multiple inheritance of classes? So already given, but let me give you one more time. We already said that Java doesn't support multiple inheritance, but we haven't really explored why. So let's try to do. But we have given already ABC classes. I explained you very clearly. If Java had multiple inheritance, child classes wouldn't be able to decide which specific behavior they should choose. So here two classes I am implementing: toaster and nuclear bomb. And so toaster is on. The toaster is on. So this is the just a simple method, on and off methods we implemented, and nuclear bomb on. So this is the another method, right? So this class has a on method, and this class also has on method. Same method in two classes. That's what I told, right? So if two classes having same method, and which behavior it has to call? As you can see, both have on method. For a toaster, it starts toasting. For a nuclear bomb, it sets off an explosion, right? That's the two classes on method behaviors we have defined. So now you want to call them to create something in between, and thus you have mysterious device class. So this is we are creating. So public class mysterious device extends toaster comma nuclear bomb. So that means two classes you are trying to extend to this class. So now immediately you will get a mysterious device dot on. So what should happen here is it doesn't understand from which class it has to pick up this on method. That's why multiple inheritance is not possible in Java in case of class. So let's take a look at what we have. Mysterious device simultaneously inherits toaster and nuclear bomb, but both have on methods. As a result, if we call the on method, it's unclear which one should be invoked on the mysterious device object. There is no way the object could ever know which method it has to call. On top of it all, of the nuclear bomb doesn't have an off method. So if we didn't guess right, it will be impossible to disable the device. These are all the reasons, so we cannot do that. That's why it doesn't support multiple inheritance. Okay, so any doubts here? So this is a simple example you can take up this abstract class. So let's go to the examples. If any doubts, let me know. So what is abstract class? A class which has abstract keyword, then that class is called abstract class. And abstract class must have at least one abstract method, and remaining all other methods you can create, like normal methods or concrete methods we call them. Constructors you can define, variables you can define. So what is abstract method? A method that is just declared and which doesn't have a body. So no definition you are giving. And so you can implement some methods. That means, so in the abstract class, you have some methods implemented, some methods are not implemented. That is an abstract class means. You should not create an object for abstract class. We should not create an object for abstract class. Okay, any questions? Before going for the same car class we can take, and we can
Ramesh, when you said when you can't create objects for an abstract class, but we can create the objects to their subclasses, right?
Subclasses are not abstract class, right? It's normal class.
Okay, then you said constructors are allowed in the abstract class. Then why can't we instantiate an abstract class here? Then?
It won't allow you because there is no behavior, right, for the methods. Without behavior, how can you use? If you create object, you should call the method, right?
Oh, okay. Yeah.
Without behavior, how can you use that method?
Correct. Yeah.
That's why if there is no behavior, we cannot use. That's why they are not supporting it.
Got it.
If you create, you have to use that method. Without defining that method, how can you use that method?
Yeah.
That's why they are not supporting object creation for any abstraction process. And why we need this? You can write your own logic in different classes. That's why you're declaring abstract methods. It's not a common behavior. It's not a default behavior. And you want to give for the same method different logic in different classes. Then you declare such kind of methods and abstract methods so that each class and you can implement your own way. A shape abstract class, area, method, and perimeter. Area and perimeter is same for all the different shapes. Then you can take up this as abstract methods here. Another best example for you. So take up this example and implement for different shapes this abstract methods and implement. So what you need to do? You create an abstract class shape and declare the abstract methods. One is the area method and perimeter method. And you can implement this in different classes, normal classes, circle class, triangle class. Triangle area is different, circle area is different, rectangle area is different. And you implement your own way there. This is the where abstract class and interface to plays a major role. I hope you got now why you need abstract classes.
Yeah, yes, Ramesh. Yeah.
So you want to give for a few methods different logic, but the method is same and the behavior is not same for all other classes. Such kind of scenarios, you declare that method as an abstract method. Later in the child classes, implement that method in the way you want in that class. What logic you want to implement for that method in that class, that specific class method logic you can write for that method. That is what the abstraction comes into picture. The same behavior means you don't need to make it as a abstract method. If it is a same method, you want to give different logic based on the class, make that method as an abstract method. The best example is the shape class. You create abstract class and declare one method is area method, perimeter method, and draw method also. You can make it and declare some other methods you can implement. Normal methods you can implement, and maybe you can implement a draw method. Okay, draw method also it's a different, right? Based on the shape you can implement. You can draw the shape. And area method, circle area is pi r square, right? And that method you cannot implement here. And again, triangle area is different, rectangle area is different. So all these are best. Okay, now see that how to create an abstract class. Abstract car. So choose this abstract tick box, then you can create. That's why we created a final class also. Final class we created, and here also abstract class also you create same way. So click on finish. I'm not just creating all these things. Okay, so just I created an abstract class, and I can create a private, all private methods. Let me take from here, quickly finish. So these variables, so will generate, I'll just Control Shift F, format will happen, and generate setters and getters. Source, generate getters and setters. So select all, done, very quick, right? you can generate setters and getters. So I'll keep in top. So now I'll declare abstract methods. So public abstract provide gas method. So this is an abstract method. Another one, even you can give protected also, no problem. Protected abstract provide break method. So these are the two methods I want to define for my car classes differently. So differently I want to give for the same method, different logic, every class, different logic I want to write. Then I can declare them as an abstract methods. So these are all concrete methods. Concrete methods means defined methods. You have a definition for those methods. And these are the methods which doesn't have a definition. I can implement this method's logic in my child class. Okay, so that's the abstract class means. At least one method must be an abstract method. What is the exercise you need to take up? Shape abstract class you create and declare two methods. One is the area method, perimeter method. And other methods you can create a normal methods also, few methods, any dummy methods you create in the shape class. And then you can create a child classes for that shape class. What are the child classes for the shape? What are the different shapes you know? What are the different shapes?
Circle, triangle, rectangle.
So these are all the trapezium, so rhombus, so many shapes are there. Any shapes class you can create, and based on that class area will change, and you implement that area method logic. I hope you can write that. If you have any problems, you can come back. Now I'm creating a normal class. I told you, how can you implement these methods in my child class? You need to use extends keyword. You extend this abstract class and implement these methods there, right? So let me create a sedan car. Normal class I'm creating sedan car. So you can take, if you want, you can take the main method, then you can execute sedan car extends car class. See, it is throwing error. It is asking add unimplemented methods. Only unimplemented methods definition you give here. That's what it is saying. See that. So the logic automatically it is coming and body is coming here for the unimplemented methods. Which methods we haven't implemented in the car abstract class, that methods is coming with the body here. And it is saying clearly, and you implement them. So I can say, okay, so then you can write your own implementation. So each class you can implement your own way. Sedan is going down when you apply brake, right? So this is a simple definition I have given for these methods, my own way based on my sedan car. Same way you can give for others also. Okay, so you can create object for sedan, right? Sedan car sc equal to new. Even you can use new sedan car. And otherwise you can use runtime polymorphism also. Runtime polymorphism once, so you can create a car. Okay, so then what will happen? Only the abstract methods of the implemented methods, overridden methods, only overridden methods. These are two methods we are overriding, right? These two methods you are overriding here. Method overriding also coming here. This you can give any examples. So parent class, that reference variable pointing to child class object. And now you can call sc dot gas method and sc dot break method. And even you can call sc dot other methods are there, right? Car model. So what are the max speed, get max speed, set model or setter methods? Set color, I can set the color to blue and sc dot set model. So what model you want? So I can say is sedan, right? I can just write something, whatever you want. Okay, set max speed. So the max speed I can give to 150. So like this you can set and you can get all the methods. So this is the runtime polymorphism concept you're using, or you can create a normal this sedan car object also. You can pass here either parent type or child type, anything you can use. Okay, is it clear? So that's how you can call all the methods and implement your own way for these methods. I hope you are clear. Or still any doubts, let me know. Or what you can do, you can create a constructor instead of the setters and getters. You can create a constructor. So what you can do, you can create a constructor, public car. So you can see string model, string color, and int max speed. You can define, so this dot model equal to, you can define model. So this dot color equal to, and I'm just assigning the value color. So this dot max speed equal to max speed. Like this you can implement. Then you don't need a setters again, and just when you create a car class, automatically you can define here. Okay, so it is asking, so constructor also you can call, add constructor here. So it is asking automatically super keyword, right? Super model, color, and max speed. So when you create object for this, you have to pass all these names instead of this setter methods. You can pass directly here. Then you can call getter methods. This other way also you can do. So this is how you can do. Then you don't need these setter methods. You can call getter methods directly. So either you can use setter methods, one way you use, not necessary, all right, one way you use. Okay, so that's how we can call all the either through constructor, through setters and getters. You can pass these values, these variable values. So we have seen that. See that here you are getting a encapsulation, and you are getting again inheritance, and you are getting again method overriding. See, in one or two classes you can have more OOPS principles. More OOPS principles you are using here. So that's how you can correlate and you can explain. So simple example you take and explain them. So can you explain me this, all these points? This is the one class you can take and you can explain. Method overriding also coming. In the car class you didn't define them, but this structure is different, right? This method structure is different, and you are changing that logic here. The logic differently you are implementing here. That's a overriding. Method overriding is coming here again. So the rules for method overriding, what is that? So you need to extend, then same method you have to write, and the body is different. So the body is only different, remaining all same. Remaining all same. Method overriding also coming, inheritance is coming, and so that's how we can explain. Okay, any questions before going to the next topic, interface?
Ramesh, can we inherit one abstract class from another abstract class?
You can inherit, but you cannot implement. Yeah, you can do that. You can do one class, you can implement, extend another abstract class. You can do that.
Okay.
Again, that abstract class also must have one abstract method at least. Again, that abstract class can implement. These first abstract class methods you can implement there. Right? That has
Correct,
both.
yes.
Abstract class means what? Some are undefined, some are defined. You can define them in the second abstract class, which are not defined in the first abstract.
Okay.
You can do that. You can do that all. That's all about abstraction. Any questions before going most important topic, interface?
రమేష్ గారు, మీరు కార్ దాంట్లో గ్యాస్ ది అండ్ సెకండ్ బ్రేక్ దానికి మెథడ్ లో మీరు ఏమీ కూడా డిక్లేర్ చేయలేదు కదా, ఇవ్వలేదు ఇన్ఫర్మేషన్.
That's what abstraction means. That is what abstraction means. I want to define for these two methods in different classes. For example, I'll create one more. This is the sedan car. I'll create a SUV car. SUV car is different, sedan car are different, right? And I can define for a SUV differently for this method, and brake is differently I can define for them. Not this logic, right? I can create another one more class and same I can implement. So SUV car. I can implement my own way here also. That's what I'm saying. This abstraction comes into picture here. The first constructor you have to add, then it will ask you add unimplemented methods. See that you can write your own logic here. So I can write different logic here. I'm not writing my same logic that I have written for sedan car. You got it? The same methods, you can define your own logic in different classes. That is the way abstract methods plays a major role. You don't want to give a same logic for the method, predefined logic you don't want to give the same logic, but you want to give it for the method same, but logic you can change in the class wise. That's where abstract.
Same as override. Okay.
So overriding only. Every method you are overriding in your child class. You are giving your own logic, and when you create object for this class, this child class, you will get automatically this logic for you, not other logics. Whichever the class object you create, and that logic you will get. That's what the runtime polymorphism talks about, right? So at runtime, the method call will be decided based on the object. The overridden method is called based on the object time at runtime. Clear? That's what we discussed at runtime polymorphism. These are all the places we are applying the runtime polymorphism. Car CA equal to new SUV car. I can write a red, and next one is model first. Then this model is SUVs, and I can like this. You can create a different types of cars, and then what will happen? Which object you created, so that object brake system will come. That is, you are not calling other thing. It is calling this class logic. It will call here, and that's the method overriding a runtime polymorphism. Overridden method is called here. This see that a parent class of type pointing to child class object. Okay, so we explained too much, and let's move on to any other questions.
One last question, Ramesh. So when we say abstract is kind of a hiding implementation, so exactly this method of overriding is the hiding part here?
Not right. So in the car class, you are hiding. You're not showing the logic here, right? So this for these methods, you are not writing the logic here. You're not showing for the users. You will give a abstract class for the people, and here they cannot see the logic for them. Are you seeing logic?
The actual logic. Here? Oh, I got it. Okay.
Here you are completely not showing any logic here. You just declared. That's it. In the other classes, you are implementing, but here for a few methods, you are showing the logic. The implementation is happening here in a few classes, right? So that's the.
Got it.
So partial abstraction you can achieve with abstract class. Partially you are abstracting, and partially you are showing the logic.
Okay, got it, Ramesh. Thank you.
Yeah. Any other questions?
No, sir. No, sir.
No, sir.
Okay. Now let's move on to interface concept. What is an interface? Second abstraction process. First abstract class used to achieve the abstraction, but partially you are achieving that. Not 100% you are hiding the entire detail from your abstract class. Only partially you are hiding from other classes. You're not showing the logic directly here in your abstract class. And for 100% abstraction, you can go for the interface. The interface is another blueprint or template, same as a class. So, but this this interface has abstract methods, default methods, static methods, and constants also will be declared. There you can declare variables, right? Where static variables and non-static variables, both in the abstract class. But in the interface inside, you can declare only constant variables. Constant means, how can you define the constants? How can you declare constants? final keyword you are using. So that's how you can declare constants. Public static final by default. Okay. Since Java 8, we can have a default and static methods in the interface inside. Java 9 onwards, they added private methods also. If you have a Java 9, you can write a private methods in the interface. Before, in Java 8, private methods are not allowed. Why you need to use a Java interface concept? It is used to achieve abstraction. By interface, we can support multiple inheritance concept. In case of class, multiple inheritance is not supported. In case of interface, you can achieve multiple inheritance concept. How to declare an interface? You can use an interface keyword to declare your interface. You're using a class keyword to declare a class, right? Same way here, you will use interface keyword to declare interface. It provides a total abstraction, means all the methods in the interface are declared with the empty body, no body at all. So we are not empty body also, without any body. You can declare them and later you can implement in different classes. And all the fields are public. That means static, public, static, final by default. All the constants are by default, public, static, final. These three keywords will come automatically in the constant declaration. No other access modifier you're going to use for the constants. By default, public, static, final. See that public is access modifier. Static and final, what type of access modifier?
Non-access modifier.
Non-access modifier. So see that both modifier keywords are you're using here in the interface. So a class that implements an interface must implement all the methods declared in the interface. So class only implement the interface. Implement means what? It is writing the logic for the interface methods. Class inside that methods you are overriding in this class. So that is what this interface, how you are going to implement. But you will use implements keyword between class and interface. So like this, class implements the interface. Again, you should not create object for interface. Why you should not create object for interface?
It is static nature.
Sorry? And what do you understand in the abstract class?
There is no body, though no implementation.
No implementation. That's the answer. There is no implementation for the methods. Without implementation, how can you use that methods if you create object? That's why interface also doesn't allow to create object. Any interface, it doesn't matter what interface it is, and it won't allow to create object. So Java compiler adds public and abstract keywords before the interface method and public static final keywords before your constants. The syntax of interface is access modifier, interface, interface name, curly braces start, into words. And even if you don't write also, by default, these three keywords will append internally. Abstract methods means, so if you write abstract method name, parenthesis, semicolon, public abstract, return type, method name. So public and abstract keywords will add for your abstract methods by default. You don't need to write also. So by default, internally it includes those two keywords for the methods. And default method starts with default keyword, default void method name, but you can implement this default methods. And static methods also you can implement. So that's these two are added in the Java 8. So these two methods added in the Java 8. So, and naming conventions of interface is every word first letter should be capital, same as a class name. Okay? How you will write a class interface also you have to write the same way. And a class name implements interface name. So that's how you will implement the interface inside the class. So public class Firefox driver implements WebDriver. So here WebDriver is an implement interface, and this WebDriver methods you are implementing inside the Firefox driver class. Then how can you call this? Okay, you implemented. How can you call that? How can you map interface and this implementing class? Now this is the parent type and this is the child. So again you apply runtime polymorphism concept. Interface name reference variable equal to new implementing class. Which class implementing? That class object you create, then that class method logic you will get. Again reference variable dot method name. How can you call return type non-static methods? Return type variable name equal to object reference dot non-static method. So this is the all, and so tomorrow we'll continue the rest of the things.